Okay, pre-calc students, these are your video notes on continuity and end behavior. So most of the functions that we've talked about so far are continuous functions, like a quadratic function is continuous, or a cubic function is continuous. Even a square root is continuous over its domain. And a continuous function means that you can draw the function without picking up your pencil. But we have some types of discontinuous functions. The first one has infinite discontinuity, and that's when you have a vertical asymptote. So if you see your vertical asymptote here at x equals 1, that's going to give us infinite discontinuity at x equals 1. And if you're just looking at the function without the graph, you want to see where would the denominator be 0, because that's what would create your asymptote. So if I wrote x plus 3 equals 0, and I get x equals negative 3, that means the function has infinite discontinuity at x equals negative 3. If you have a more difficult denominator, like x squared minus 4, you might need to factor it. So you would have x minus 2 times x plus 2 equals 0. And this function has 2 points of discontinuity. One is at x equals 2, and one is at x equals negative 2. So infinite discontinuity at x equals negative 2 and x equals 2. Okay, on the next page we have removable discontinuity, and this would show up in a graph as a whole. And you see this when you can factor the numerator and the denominator, and the factors cancel out, meaning that you would not actually have this asymptote at x equals 2 in this case. So I'm going to factor my numerator, and I get x minus 2 times x plus 6. And then the x minus 2 and the x minus 2 would cancel out. So your simplified function is just x plus 6. It seems like your function would just be a line. However, if you were to plug negative 2 into your original function, you would get a denominator of 0, and that would be a problem. So that creates a hole in your graph. So we would say that this function has a hole at x equals 2. The next function, we need to factor both the numerator and denominator. So the numbers that multiply to 6 and add to 5 are 3 and 2. X plus 3 times x plus 2. The numbers that multiply to negative 15 and add to negative 2 are negative 5 and positive 3. So the factor of x plus 3 cancels out, and that means that you would have a hole at x equals negative 3. But you also are going to have an asymptote at x equals 5, because that factor did not cancel out. So I'm going to have infinite discontinuity at x equals 5. All right, and the last type of discontinuity is a jump. And on a graph, that literally looks like you're following one function, and all of a sudden you have to jump to the next function. So you have to pick up your pencil, and that would be a discontinuity. Usually you'll see that from piecewise functions, but sometimes piecewise functions will be continuous because they will pick up at the same point. So let's see what happens here. I know that a linear function is continuous, and the second linear function is also continuous, but what happens when x is 2? If I plug 2 into x plus 4, I have 2 plus 4 equals 6. So my y value would be 6 as I'm approaching 2. In the second function, I have 2 times 2 minus 3, and that would give me 1. So that means that my y value is going to jump from 6 to 1. And so I would say that I have a jump at x equals 2 when I switch from the first function to the second function. In my next example, I'm going to substitute negative 1 into the x squared minus 2. When you square negative 1, you get positive 1, so I have 1 minus 2 equals negative 1. And I substitute negative 1 into the second equation. I have 3 times negative 1 plus 2. I also get negative 1. So even though these two pieces are separate pieces. They join at x equals -1. So this function is continuous. Let's look at these examples here. You should try the examples before you look at the answers. So the first one, I can see the asymptotes here, so that's an infinite discontinuity. Sometimes we just write asymptote. The second one seems to be some sort of piecewise function, but it is continuous. I don't have to pick up my pencil anywhere in that function, so I'm going to write continuous. The next one, as I start from the left and I go to the right, I have to jump to get to the second piece. So this discontinuity is a jump. And the last one seems continuous except for this hole right here, and that is a point of discontinuity. All right, now we're looking at some equations without graphs, so I'm going to factor. I have x plus 1 times, nope, that's going to be x plus 2 times x plus 3, and the denominator is x plus 3 times x plus 4. All right, so x plus 3 cancels, which means that there's a hole at x equals -3, and I still have an asymptote, or an infinite discontinuity, at x equals -4. The next one's a piecewise function, so I'm going to substitute 2 into each function. I get -4 here, and I get 2 squared minus 8 plus 1, so I get -3 here. So the function does have to jump from -4 to -3. So this is a jump discontinuity at x equals 2. Okay, and the last one is x cubed over 2. So this is the same as -1/2 x cubed. There's no x in the denominator, so this is just a cubic function, and this one is continuous. All right, so we're going to stop the first video here, and then we will continue on a new video.